Okay, so we're just going to go through these three problems. Um, they are similar to yesterday. We've just added some variables in here. So we're going to start by doing the same thing, which is the prime factors of the numbers. So if you could get your calculators out. We're going to divide by 2 as many times as we can and then keep moving up through the prime numbers. Okay, so I was able to divide by 2 3 times. And now I have to start dividing by 5 because it's not divisible by 3, so I jumped up to 5. So that's the prime factors of 1400. Now, on this first one, I am going to write out all of the variables, but I'm not going to do this ever again. But I need to give you a visual of what actually is happening so that we don't have to do this in upcoming problems. So I'm going to write out all of the variables. Okay, so that is the prime factorization of that whole problem. Now, looking back from yesterday, what are we looking for? Groups of 2, right? Okay, so we go through, we circle groups of 2. Okay. Now each of those groups, we're taking out whatever that object is, that pair. Okay, but we only write it once. So what is the number in the front going to be? 10. Okay, so we've got 10. How many x's? So how do you write that? X squared. How many y's? And z's. Okay, so the number, the exponent, that's how many groups you were able to take out. Now we need to write what's left over. What number is under there? And then variables? Okay. Questions? Okay, it is a lot of work. We're not going to write out the variables from now on. Okay, but I just wanted you to see what we were doing. We're especially not going to do this because on the next problem we're not going to write 99 y's. That would be ridiculous. Okay, so we are going to do the prime factors of the numbers though. So looking at 7,000, we get that. Okay, so we're just dividing by each of those prime numbers as many times as we can until we hit a number that we can't divide anymore. And then all I'm going to do is I'm going to recopy each of these, but I'm not going to write out all the letters. Then we'll do the same thing down here. Okay. Now, what size groups are we looking for here? 3 because of this 3 out front right here. So we've got, here's a group, here's a group, here's a group, and then we're going to talk about the letters. All right, so we have what number out front up here? It's 10, right? Take out a 2, we take out a 5, we multiply those, we get 10. Okay, so we know we have 10. Now the question you're asking yourself with the letters is how many groups of whatever whatever size they need to be, can we take out? So in this case, we're looking at size of group 3. Okay, how many groups of 3 can we take out of the A's? Okay, so we write A2. How many groups of 3's here? 2 of them. And how many groups of 3 from that? All right, so now we just write what's left under that cube root. What number do we have though? We've got a 7. And do we have any A's? Nope, we were able to take all those out, but we do have a B, and I heard a few of you say C2. Okay, now, in case you're confused on that, the reason it's C2 is because we took out 6 groups of 3, which would be 18 of these C's, so there's 2 left over. All right, looking on the bottom, what is going to be taken out? 2. How many groups of 3?
9.
How many groups of 3? 1. And how many groups of 3 are here? 33 of them. Okay. Now, there is a little bit of something else that we can do. We can simplify this a little bit more where? You can say.
10 divided by 2.
The 10 and the 2. Yeah, right here. Right here and right here. So what are we going to do to simplify it? Make it 5 on the top? Okay, so we really have 5a squared b squared c6 cube root of 7bc squared over, now we just have x, y 33. Questions before the last one? This is the most common mistake, is kids will forget to write that root number on there, so don't forget that. If it's there, it needs to stay there. We good? Okay, last one then. So now we're looking for groups of 4. There's no numbers, so we don't have to worry about any prime factors. We can just start asking ourselves, how many groups of 4 can we take out of each of these? Okay, so looking at just the top, how many groups of 4? Just 1. How many groups of 4? 0. We can't take any groups of 4 out of that. There's only 2 of them there. How many groups of 4? And how many groups of 4? So what are you putting in your calculator to find these numbers? Like how could you find 30? Yeah, you're taking that exponent 121 divided by 4, and you're going to get 130 and 0.25. Okay, so you know you can take out for sure, not 130, 30.25. You know you can for sure take out 30. Okay, what do we have left after we did that? How many W's? How many X's? Any Y's? Any Z's? All right. Looking on the bottom, how many groups of 4? How many groups of 4? How many groups of 4? Anything we can simplify on this one? No, so that is your answer. Questions?